Good afternoon, everyone. Hi, Vivek. Nice to see you. Hello, Mukul.
Hello, sir.
Hi, Nandini. Hello, Swati, Sujal. So, did you all go through the notes for compass error? Let's take a look at
Good afternoon,
those
sir.
different errors. Good afternoon, Utkarsh. Nice to have you. Sujal, how do you read?
Read you 5, sir.
Very good. Yeah. So, Mukul, go through the notes on errors, everyone. Take a quick look. I'm going to ask a few questions. I want to see if you're aware of the values. What happens on which heading when it comes to turning error or acceleration error? Okay. We understand what is the meaning of this error on a compass. It is the difference in the reading, actual direction, and the visual available direction from the compass. The compass can show you more, the compass could show you less. It means the pilot has to take actions not looking for the desired direction, but a little less or a little more. Okay, this is the practical application. Right, Mukul? We understood this much about the errors.
Yes, sir. I have not yet revised this.
Sorry, say again, Mukul. Read you 3.
I have not revised this errors.
Okay, go through the notes now. Go through them now. Let's do this exercise, everyone, quickly. What about you, Vivek?
Yes, sir.
Did you go through it?
And not with compass errors, but all
Why
that
not?
we had.
Did you not get the email notes?
Yes, sir, I was.
What about you, Nandini and Suju? Nandini, tell me.
Sir, I read the notes, but not the error part. The turning error part, I didn't.
Say again. Wait, I think I cannot hear properly.
Sir, the turning error part, I didn't do.
Okay. Go through the notes now. Let's take a look. I want to show you how to answer questions related to these points. Okay. Because that is more important. The points are easy to memorize. The table looks easy. But we need to understand how the questions be in order to give answers as per the table. Utkarsh, how do you read?
Read you 5, sir.
Good. I read you 5. So, everybody, do you have the points on the compass errors? I want it to be open book for now. That's why. When I say I'm going to ask questions, it's not a test. I want to help you memorize these. These are important points. It's a simple table. This is like a monkey that will always be on your back. It will always scare you if you're not thorough with it before the examinations. So let's just get it off. 1 or 2 questions also are important for us, right? If I talk about deceleration error, what does come to your mind? The first 2 points. It is maximum when my heading is easterly or westerly. The first point in the notes, right? For deceleration errors. So let's run this by in our minds quickly. Easterly or westerly heading. It means whenever I'm flying in the direction, when my nose of the aircraft is pointing towards east, what is east? 090. What is west? 270. Heading. Heading is the direction in which the aircraft longitudinal axis or the nose of the aircraft points. Now the heading and the track, it's going to be almost the same, all right? It's just a little bit of a drift correction wherein your heading and your track will be a little different. But we understand we are flying in that direction, we are maintaining a heading similar to that. So most of the times it will be the direction that is going out. You're going on that direction. So if let's say that this is your station, okay, and this is not facing you right now. Like I am not. You all assume that your left hand is the station and you all are pointing north. Okay. So what will be your heading and your direction of flight when I say heading is east? Jeet, welcome back. Hussain, welcome. How do you read?
TD5, sir.
Good. So I want you all to open up your compass error sheet. You have to do this exercise. Okay. So everybody left hand, this is your station. You're tuned to, or you want to go to this station. Okay, right now. Okay. When I say east, what does it mean? This is not everyone. So this right, this is east with respect to this station. This is east. You're going here in this direction is east. So your heading will be 090. Track you're following when going away, if you're tuned to this station, will also be 090 away from the station. That is very important to remember. Away from the station. It means the same thing. But right now, if I follow 090, I'll be going that side. I don't know if my station is ahead of me or behind me, but this center is the station, and from here it is not. With reference to you, everyone. Okay. What is west? West is this side. How do I get to west? Either I can take a left turn. How many degrees will I have to turn now? 90 degrees to the left. Or I can take 270 clockwise. Directions are always measured clockwise from reference north. So the value of west is 270. I can also get 270 by deducting 90 degrees from 360. 360 minus 90. You get 270. This is west. Okay. Now let's say your plane is here right now. Okay. Our plane is right now here. So what is the heading of the plane coming to this station? And what is the track of the plane coming on the station? The plane is facing in which direction? It is this direction. What was this direction? It was west. But what is the track of the aircraft right now? It is on 090 with respect to this station. These are the two things that will always confuse you, but not anymore. Your track, okay, 090 to the station. My heading is 270. Your questions will be tricky, okay? They'll not be as easy as fill in the blanks, okay? Deceleration is max on dash. And options east, west, north, south. Such questions could also come. If they come, great. But the problem would be when they'll say you are on a track to station 090. So you need to understand where you are. And then they can tell you your heading could be anything then. Your heading could be 270. Your heading could be 180 also if you're maintaining that track. Heading would be different. If they give you that track, it means this is your position right now of your plane. This is your position right now. This much you need to understand. Whenever you're talking about heading, again, it is the magnetic heading 000 north clockwise. So now in the question, if they tell me your deceleration error will be so you're on a track 090 and the station with respect to you is at a relative bearing of 000. Okay, a relative bearing. Now what does it mean? This is my aircraft, this is the station. Track to the station 090. Heading, what is the heading here? 270, because I'm going in west direction, see like this. What is my relative bearing? It is dead straight ahead, that is north. What is relative bearing? My aircraft longitudinal axis and my station, they both are straight ahead right now. If I am over here, are you getting it? What is relative bearing now? So in the question, you will get a point wherein aircraft is at an RB, relative bearing of 000 or north. They can replace 000 with north also to confuse you. You are on track 090 to the station. Your deceleration will be option maximum, minimum, or something in between. Simple. This one point can be given out to you in such ways. So you will think if my relative bearing is 000, they will try to distract you and keep in your mind that your heading is north right now because your station is right ahead. And relative bearing has nothing to do with your deceleration error. But because we know deceleration error is 0 on north, you might mistakenly mark 0 as your answer. Because you'll think going north, station is straight ahead of you. That is not how it is. Station could be straight ahead of you, but your magnetic direction, your heading was 270, although your track to the station was 090. So in that case, you will say your deceleration error is max. Why? Because whenever your heading is east or west, deceleration error is max. So you have to have this understanding. Now, this is the deepest level of understanding questions in terms of directions. Half of your questions will be given in with this respect. Are we all following what's happening right now? We will keep repeating relative bearing, distance to, distance from, and heading. Okay. Anytime you are confused, you can ask, but you have to master this concept. These three are different things. And one position, you will have three different things. You understand? Then one more thing we'll encounter, which will be track made good or track error. That again will be the fourth element. So your heading would change then. The required track and heading would change because of the TMG. Are we following this? This is the base. I want a refresher right now. I don't want to just go ahead with all the topics with you, not realizing this basic point, because this will be a root cause for confusion. For students who have not flown much and asked questions like this on paper. So visualization is very important. What helped me is always thinking first where the station is and determining the north. That's it. And everything clockwise. The first thing. Second thing that will help you, as it always helps me, is to know the difference between distance to and distance from track. Track is the path traced by the CG. It is like a road. Your heading could be anything. It could be as good as the track, opposite to the track, a little different from the track, depending upon the winds, whether you're going to the station, from the station. The term whenever relative bearing comes, it is just you and the station you're flying to or tuned. Flying to will be when the station is a destination. Tuned to could be when the station is a destination or it is just acting as a navigation aid. Flying in between, it will help you. You can maintain a relative bearing. So let's assume the in-between scenario. I want to fly to you right now, following a northerly heading right now. Okay, but my range from your station is too high. It means my ADF, automatic direction finder, the one which gives me relative bearing, I cannot sense it where I am right now because the range is not enough. But I want to go and I want to make sure that I am not deviating. So to reach you, let's say you are at 1000 nautical miles from me. The range will not be 1000 nautical miles for your ground station. So in between, there will be more ground stations which I can use as a reference. They might be on my right, they might be on my left. Okay. My required track is 0902 to the station right now. And there is nil wind. So my heading will also be 0. Correction. My required track is 000 north. And my heading will also be 000 north. There is no drift. Okay. It is very easy for me from Mumbai to fly to Delhi because I know the route itself has 007 as its directional value. And I always think Delhi is north a little bit to my right. That is 7-degree angle from north. That is the actual on RT charts. You will see the radial 007 is mentioned over there. But it is okay. Always think north like this. Then the second thing will be okay. So let's say my range for my ADF is say 200 nautical miles or 300 nautical miles, or maybe a little more because it uses lower frequencies. Okay. Let's say there are two NDBs en route. One is here of my, okay, one is on the left at 400 nautical miles, one is on the right at 800 nautical miles, and then the destination, your end, at 1000 nautical miles. So I have been told that I can navigate using these if I maintain a certain relative bearing. Okay. So all I want to do is once I've tuned into my ADF, for ADF number 1, my indicator will point to the station. You will see how to read the indicators. Today we are only talking about the number. And where is my station right now? It is on my left. What is on my left? West is always on my left. West is always on my left, here like this. So my relative bearing, what would it be? My longitudinal axis is this. Clockwise, from here like this to the station. It is always measured from your longitudinal axis to the station. But because it is ahead of you, it will not be exactly 270. It will be at an angle right now, like this. So how much would it be? Probably, I think it is 315 right now. So you will imagine, because you are here right now, your left hand, keep it at 315 right now. That is your station. So when you are on your airport tuned into this, you will see your relative bearing is 315 with respect to NDB 1. The moment you fly 400 nautical miles and reach this point, your relative bearing will be 270 for the same station. And the moment you start moving 400 nautical miles more ahead, it will go behind and it will be somewhere between 180 and 275. You understand how I'm calculating it? With respect to you, its physical position will also determine your relative bearing. It will not always be 315. It will keep changing. It will keep changing. The moment you are parallel with it, it will show you it is exactly at your left. Isn't it on your left? Exact left. Look like this. It is exact left when you are parallel. When I'm going ahead, it is behind me. What is that point? I know it is between 270 and 180, like this. So it will be somewhere around 225, 235. It is all a game that we can play considering 360 degrees measured clockwise. It is always easy to have north, east, south behind me, and west. You don't need any instruments. You can do all with your own sense of understanding just looking at a compass. Because the compass will give you north. Correct? You understand what I'm trying to say? So far, are we following what I'm trying to say, the exercise? Are you trying to imagine everyone? Do you understand if NDB1 will keep changing its relative bearing? Initially 315, then 270, then 225. Yes or no? One by one, please speak.
Yes, sir.
Yes,
Affirm, sir.
Affirms.
Sujal, Swati, Utkarsh.
Affirm, sir. Negative, sir.
What is it that you did not understand, Utkarsh?
So the last portion that like you were explaining that right now.
Yeah, be specific about it. Talk about how much you have understood and what you did not understand. Walk me through your understanding. Everybody, please observe, okay?
So I don't know how to explain. Like
What have you understood so far? Utkarsh, be brave and speak up. Don't worry. Anything, something you would have understood, right? It cannot be that you didn't understand anything.
like
Try. Yes. It all starts with this first thing.
I don't know how to explain. Like
Talk about what's happening. See, this understanding, the beginning, what's happening, we are going to a destination that is directly straight ahead of us. It means we have to follow a heading straight ahead of us. And I'm telling you that the direction is 0, 0, 0 for you to fly. And there are no winds. So your wing, your aircraft, everything is going in that direction. And this is north.
yes,
Okay.
sir.
This is north, and the destination is at 1000 nautical miles straight ahead. Right?
Yes, sir.
Now I am talking about relative bearing and the changes in relative bearing. Because we have understood in this example, what is the track to go to the station right now? The track to go to the station is, who can tell me what is the track to go to the station? Required track
000.
09. 090.
000.
000.
Sir,
Yeah. Think about it, students. Required track to the station, QDM. Yeah, Utkarsh, tell me. Vivek, you're
so
not answering.
090.
Yes, sir. It's 000.
Mukul, Jeet, Hussain, Nandini, Nikki.
000.
Not
So 0, 0.
000.
000.
Think about it. I'm talking about QDM. I'm not talking about my direction of flight right now. My reference is straight. I want to fly straight, maintaining a heading of 000 to reach my station. And the station is straight ahead at naught right now. My naught. There is no wind. Station is ahead.
So 000.
What's the definition for QDM? Does anybody remember? You got 3 days, right? 3 days should have been enough to revise everything done in navigation so far.
Magnetic heading from aircraft to station.
No, not a correct definition for QDM. It's confusing. It's okay, take your time.
magnetic direction to the station.
Magnetic direction to the station. Okay, that sounds relevant to me. Sujal, no inputs? Class, come on, everybody has to discuss.
Magnetic bearing.
Bearing. Hussein, find out your notes, the definition, quickly. Read it out straight from the notes.
Magnetic direction to the station.
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 What did we learn about these directions? There is a small cardinal point sort of thing made for QDM. My direction of flight. Okay. Hussain, did you find it?
Yes, a magnetic direction to the station.
Nikki, what about you? You're not responding.
So magnetic direction to the station.
Magnetic direction to the station. Correct. As per the diagram that we saw, 000 comes below, right? So if I follow magnetic direction 000 to the station, I'll reach the station, right? Good. 0980, no. 0980 is on our east right now. We're not talking about 0980. It could be 180 also, right?
Yes.
It could be 180 also. Does anybody think it could be 180? Because we are at 180 from the station.
QDR.
It will be the QDR from. If I'm going away, that is the magnet. But I'm not going away. That is the QDR. So I am opposite of QDR, that is QDM. And opposite of QDR is QDM. Opposite of 180 is 0. Very good. So all your answers were correct. Very good. You didn't give an under pressure. But we need to understand why. Okay. It will be, there are chances that you might be confused. When you do radials, okay, when you do VOR, in VOR, the same position right now would be called as radial 180, because radials are always measured with respect to how you measure QDR from the station. So although you will be on a track QDM, that is 000, maintaining a heading 000. Your radial with respect to the station, if you're tuned into the station, will be 180 because you're on the line coming out from the station, that is QDR 180. Just keep this mental note right now. This is the last and final thing you have to learn about these, all the number game and direction rules. Okay. But we are not doing radial right now. We are not talking here about, we're talking about 8. Utkarsh, have you understood now everything?
Yes, sir.
Swati, you following?
Yes, sir.
Anybody has any confusion right now? This will help build a lot of confidence. So let's just quickly get done this with the example, and then I'm going to show you a small diagram of what we are imagining right now. So my relative bearing would be 315, 270, 225 if I'm continuing to tune to this station. But if I've crossed 400 nautical miles, why not tune into the next station ahead of me? NDB2, which is on the right. So I'll change my ADF frequency, and my ADF system will tune into seeking that station frequencies that it is transmitting. And now my indicator will point in that direction. So now when I have crossed 400 nautical miles, and now I'm switching on to NDB2, what will be my relative bearing? Make your guess. Think about it.
Can you say
Around
the
40.
question?
045.
Just wait for your answers. Think about your answers. I'll take your call sign and then you give me the answers. Okay. Think. I'm still at 400.
Say again.
Considering the same example, it is on the right. Range is 800 from the station where I was, but I've traveled 400 NDB2. Okay. What is my relative bearing? That's it. Relative bearing is measured longitudinal axis to the station. That's it. Position 1 when I'm at 400. Position 2 when I'm parallel, that is 800. That parallel word is actually abeam. Abeam is the word when you're 90 degrees from the station. It is not head on, it is abeam because it is 90 degrees to your right. It could be right or left. That is abeam, A-B-E-A-M. Okay. And then when I'm going ahead, crossing 800 to 850, 900, if I'm still tuned into that NDP, what will be my relative bearing? Okay. Utkarsh, are you understanding the exercise? Nikki, Swati?
Yes, sir.
So can you repeat at which distance I have tuned to second NDB?
400 only. The moment you are abeam NDB2, NDB1, you change to NDB2 to move ahead. So basically for your NDB1, you will come across only two relative bearings. The range, I'm just saying the range, minimum and maximum. 315 and then 275. The range will reduce. Your questions would come in any language, okay? They can come, questions could be like this also. What will happen to your RB range? Will it increase or decrease when the station is to your left and you're going on to this heading? Are you understanding? They can draft any question then out of this basic knowledge. You have to be very thorough with this understanding. Simple as that. Learning from the book is different, and then understanding and converting it into questions and understanding any given situation where you are. That is the ultimate point. And this is comprising everything: instrumentation, radio nav, and general nav. Just understand. Okay. And we are talking about the values, not how to read the instruments. Once we understand how to calculate it, you will realize reading your instruments, they will give you 4 different readings and tell you which is the correct reading. Understanding your sense without looking at the options will determine which is the right reading, and you will find that in the instrument, and that's it. Okay, that's our objective. That's how you become good at clearing in your first session. Good. So the question goes to Hussein. But I don't think we have Hussein. Sujal?
Sir, we have just crossed 400 nautical miles.
Yeah, at 400 from station, you tune to NDB2. And I've told you where NDB2 is. It is 800 actually, but on your right. Simple as that.
It can be 045.
045 when you are at 400. Like this, give proper answer. What about when you are at 600?
060
Okay. And what about when you're at 800?
090.
090. Good. Makes sense to me. I'm not sure right or wrong. Nandini, what do you think is the answer?
Sir, it's 400, it will be 045.
600, 800?
600, 060, and 800, 90.
So your and Sujit's answer is matching. Okay. How about you, Utkarsh?
So
Just try, right or wrong. You have to choose from 0 to 360. It is okay if you're wrong. Don't be nervous.
so at 400 nautical miles, we will be at 045.
Relative bearing RB045. Let's construct our whole sentences, everyone, as we are proceeding from one student to other. At 400 nautical miles, when tuned to NDB2, my relative bearing would be 045 at an NDB situated right of track at 800 nautical miles. See how confusing the question would be if you don't understand this. There's so many numbers, but when you understand it, it is so easy. Correct? Okay, proceed ahead. Utkarsh,
So at 600 NDP, we would be at
RB,
Zero.
relative bearing.
RB 060.
Very good. Sounds
And-
makes sense.
And at 800 RB, relative bearing would be 090.
With respect to NDB2. Very good. Vivek, what do you think
Thank you.
about this answer?
Yes, sir, the same what others are telling. The direction or the relative bearing will gradually increase as we move ahead
Very good.
on 400 nautical miles. It will be around 040. Then at 600 nautical miles, it will be around 60 to 70. And then we are again to it. It will be around 90.
090. The answers to direction should always be in 3 digits. Okay, like 60, 70 would be 060, 070. That's how we complete it. Mukul, do you agree with the answers? Yes or no? And what will be your relative bearing when you cross 900 and you're still tuned into NDB2?
So as we cross 900, it will be around 100 or 110, around that.
Very good.
And I agree with the other answers already.
Very good. Nikki, what's your observation about relative bearings? 400, 600, 800, 900. Correction. Yeah,
Sir,
900.
I'm not understanding.
We are talking about relative bearing when your station is at 800 nautical miles right of track. Okay. What is relative bearing? Angular difference from the longitudinal axis to the NDB. So we are talking about what is our relative bearing right now when we are tuned into NDB2 at 400 nautical miles along track, 600, 800, so on. What about you, Swati? Think about it, Nikki. I'll come back to you. Swati, you there? Hussein, the question comes to you next. Hussein, are you there?
Yes, sir. Can you repeat the question?
Jeet, please mention the situation to Hussein.
After crossing the first NDV, 400 nautical miles, we are 400 nautical miles to the left of NDB2, and afterwards we cross 600 nautical miles on the track and then 800.
So what's the question?
What's our relative bearing on when we have when we cross 400 nautical miles, 600 nautical miles, and 800 nautical miles?
Swati, how do you read? Nikki, are you understanding the situation? We're talking about relative bearing. Be very careful. It will be confusing, but try to focus and ask me questions wherever you have not understood anything. The first question would be, where am I? What am I doing? Always come back to this point. What's happening? I'm going to a station state ahead of me. QDM required is 0, 0, 0. QDM direction to the station. If I maintain 0, 0, 0, I'll reach the station. There is zero wind. It means my heading is also 0, 0, 0. We are talking about navigating using NDBs and RBs. Basically, we are talking everything about directions. Yannick, whatever you not understood, ask the question.
So how to find relative bearing?
Can everybody see the screen?
Negatives.
Negative.
Negative, sir.
Yeah, it will come.
Affirm, sir.
Affirm.
Okay. My cardinal points. Always, what do I do first thing? My cardinal points, magnetic directions. 0, 0, 0, 0, 9, 0, 1, 8, 0, and 2, 7, 0. Correct? Now, the question is, QDM to station alpha is 0, 0, 0. It could be or 360 also. Right? Distance to A from C is 1000 nautical miles. NDB1 is left of track at 400 nautical miles. NDB2 is right of track. This is off track, like not off track. OFF means you're deviated. Off track here means just right off your track. What is your track? 0, 0, 0. QDM to the station. Following 0, 0, 0, you'll maintain your track. NDB2 is at 800 nautical miles. What is your relative bearing? RB. Okay. When aircraft is at alpha, okay, at Charlie, tune to NDB1, okay, at 200 nautical miles along track, tune to NDB1, at 400 nautical miles, that is a beam, along track, tuned to NDB1. Okay, this is the first situation. At 600 nautical miles along track, tuned to NDB1. B, change over to NDB2 at 40 nautical miles. Give me RB with respect to NDB2 at changeover point, then I want RB with respect to NDB2 at 600 nautical miles along track. Do you understand what's happening to a simple concept when it comes in the form of a question? And this is where the confusions will happen in the exam, when you don't know how to read the question. But reading the question is just by assuming where you are, what you're doing. All these points, you have to give me the values, okay? It's not done. The question is not over. With respect to NDB2 at 60, relative bearing with respect to NDB2 at 800 nautical miles. This is again a beam along track. Okay. And then one more, relative bearing with respect to same NDB2 at 900 nautical miles along track up to here. Now the third point that I'm going to add will be change over to NDB alpha. It means NDB destination, because I'm going to my destination, that is alpha, right? Change over to NDB2 at 800 nautical miles. Okay, so I want RB at 800 nautical miles along track, RB at 900 nautical miles along track. This is it. These are what we are looking for. I hope everybody has written it down. Okay. Now I'm flying north, so my station, as I know, is over here. Okay, NDBA. This is not just for Nikki or anyone, this is for everyone. The more I repeat, the more you do it with me and understand it. Students who have not given answers, students who have given correct answer, don't take it for granted, because when you're plotting also, if you can master this, trust me, half of your everything is done. Okay? This is NDBA. And from here, you have to travel. So I'll say this is 800. This is 400. $600, 400, 200, and this is my Charlie. I'm flying from Charlie to NDB, total distance 1,000 nautical miles. Now, where is my NDB1? NDB1 is at 4,000 left, correction, 400 nautical miles left. It means this is 4,000. To the left will mean my NDB1 is here. NDB1 is located here. Okay. Where is my NDB2 located? 800 nautical miles along track on the right. This is 800 nautical miles. NDB2. Simple. This is the question. This 800, 600, 400, you can make your own. You can make 100, 200, 300, 400, 500, 800, 900. You can make 150, 250, 350. Up to you. What is the track that I have to follow? My track is this. It's this straight line, 0, 0, 0 to the station, this blue line right now. I'm assuming nil winds right now. And I'm talking about relative bearing. So what is relative bearing? We need to know. Note, relative bearing is angular difference between aircraft longitudinal axis and the NDB station. What does it mean? It means this. If this is my aircraft, then this line, center line, is my longitudinal axis. And if my NDB is here, then the angular distance would be, make an extended line like this. From your station, from your aircraft center, make an extended line like this. And then measure the difference from your longitudinal axis to this line of the NDB clockwise. Clockwise is the key. Okay. If I do clockwise, how much do I get? From north, I get 90, I get 180, I get 270, and then I get probably 45 more. So 270 plus 45, somewhere around 315. So here on the aircraft, I will see RB 315 degrees. Because where my station is right now. This is example NDB, okay, to explain RB. This is my aircraft. Does everybody understand this? Nikki, acknowledge. Utkarsh, acknowledge.
Yes, sir.
Affirm, sir.
Vivek, Sujal, Hussain,
Affirm.
Affirm, sir.
Swati, Nandini.
Yes, sir.
Now, when in my question, Jeet and Mukul, Vivek,
Yes, sir.
following,
Yes, sir.
it should be super confident right now. You should. If not, work towards it. Understand as much as you have understood. Then tell me where the problem is and the question is. We are basically tracking using NDBs. Tracking using NDBs. And a compass because we needed the QDM direction. There is no particular, what do we say? There is no particular instrument that is going to give you QDM and show you the dial. You have to figure that out. Using a compass or whatever magnetism related instrument you will have. So the first point is, when I am at Charlie, NDB1, what is my RB? Nikki, I want you to give it a go.
So 315.
Very good. Anybody who disagrees, please raise your hand. Anybody has a different answer, please speak up. No? Everybody agrees? Yes or no? And end with your call sign one by one.
Yes, sir. Victor Tango Mike Foxtrot.
Yes, Victor Tango Uniform Yankee Victor.
Yes, sir. Victor Tango Mike India Echo.
Hotel Romeo Charlie.
Affirm, sir. Victor Tango Sierra Sierra Yankee.
Good.
Affirm, sir. Victor Tango Victor Kilo.
Hussain, at 200.
So it would be approx 310 or 305.
310 or 305 at 200. Make it accurate. Try to make it accurate. I think there is at least, if you are taking this 45, then I think there is at least a 25-degree difference. Good. What was the answer? How much? 310, you're
305.
saying? 305. Okay. I'm talking about 200 right now. Was there no reply, Jeet?
Yes, okay. 285 if we consider 20 degrees.
That looks more accurate. Jeet, how about you? What's your answer at 200 nautical miles?
So around 300, 310.
Mukul?
So around 300.
And how about you, Nandini?
Around 290.
Around 290. It is reducing for everyone.
Yes.
So when the aircraft is here, my relative pairing was 315. It was because we are considering it to be at 45-degree angle. Here it shows a little 50-degree angle here. Now my aircraft is at 200 nautical miles right now. So my angle has reduced and it is somewhere around, like you said, it is reducing. Most of the times the key to understand options would be not accurate values, but increasing or decreasing. Then at 400 nautical miles, Vivek, your turn.
270.
270. Nandini?
265.
Always focus on the point where the wing, the larger horizontal, connects the longitudinal axis. That will always help you sketch it properly. Are we all following what's happening right now?
Yes, sir.
Only Nikki is following, others are following.
Yes, sir.
Yes,
Yes,
sir.
sir.
So this big blue line, it is the longitudinal axis because that's the heading again and again. So this one was direction measured like this, 315. This one was direction measured like this. That was, I think it should be, for me, it will be 295 or something in between your answers. Reaching here, it gives me almost as good as 270. 270. But the question is also asking about 600 nautical miles along track. See, I also understand the difference between along track. Along track is the distance traveled. These are key points. These are the key points. Okay. So 600 nautical miles. Let's make our aircraft quickly. Who can give me the answer? Nikki,
So 45.
look at this. Focus. It is still NDB 1. See this line. Still NDB 1. The question here clearly says alpha part at 600 along track NDB1. What is it? Utkarsh,
So 215.
okay. Nikki, coming back to you.
Sir, 19 or 200.
Mukul,
So 240.
Nandini,
250.
say again, Nandini.
250.
215. Always say in 3 digits, okay? Because you'll be expected to speak in 3 digits. Sujal, your answer?
220, sir.
So 240.
It's somewhere around 215. It is still reducing. As per your diagram, you can keep your values. It could be different than mine a little bit. No problem. Now, they say the changeover point was at 400 only though. So we were anticipating RB NDB1 till 600, but we have to change over at 400. So I'm changing over to NDB2. I'll draw this line here, changeover point. And now they are asking us, at changeover point, what is the relative bearing? When you are NDB2. So we will take green lines. And now at changeover point, this is my direction. So what is the measurement that I'm making here? It is this angle. But I'll not make it that ahead. I'll make it here. So what is the value?
045.
Who can give me the answer?
045.
Changeover point.
045.
445.
045.
Very good. Very good. NDB2, 600 nautical miles along track. Sujal,
060.
Mukul,
060.
Hussain, Jeet,
070.
you're right, 065. And then where am I? 800. Swati, what will happen when I'm at 800? Vivek, 800.
0900.
Because it's right degree, I'm making like that. This is 090. And then at 900, how much?
Around 110.
120.
120.
How much is this?
120.
Probably 120, yeah. Somewhere in between that, very good. And then last, change over to NDB at 800. So 800, we have to actually change over And when I'm at 800, what will be the along track with respect to NDBA RB? Nikki?
So with respect to NDB1, right?
NDBA. Read the question carefully. Charlie, change over to NDBA at 800. Where is NDBA? This is NDBA. This is my heading. I'm at 800. Let's make a pink line there. Right now, my heading is not changing, nil winds. The only difference in exams would be that there will be certain wind, your heading would change. And as per that heading, you can measure clockwise or anti-clockwise. Not anti-clockwise, clockwise. If your heading would change to 005, your relative bearing would completely change. So we'll put that also in the equation right now. Nikki, I'm waiting for your answer. At 800 onwards, I'm measuring this straight line, pink.
So
Yeah,
0, 0.
So 180.
Clockwise, measure clockwise with respect to this and your heading. There is no difference. 0, 0, 0, because they both are on one another. There is no angle that I can make. This is from 900 and this is from 800, the total value. Are we following? I am sensing silence in the class.
Yes, sir.
Following, sir.
Yes, sir.
Following, sir.
Following, sir.
So at 800, it will be 0, 0, 0. What about 900?
Dead on.
Head on, again 0, 0, 0 or 360. It's one and the same. Okay. Now add one point to your question. At 900, you experience drift 5 degrees port. Okay, everyone, focus now. Everybody has to solve this. At 900, now, okay, after having 0, 0 relative bearing, suddenly you face a wind because of which you have drift 5 degrees port. Okay. What will be your relative bearing to NDBA?
005.
005.
005.
005.
365, 355,
355.
The options are 005, 355, 000, 180.
So 355.
Alpha.
One by
35.
one. Mukul, your answer 355.
Yes.
First one to give that answer. Jeet, your answer.
Alpha 005.
Nandini, your answer.
005.
I'm writing options 005, 355, 000, 180. For this question. Last question. Nandini, yours is also 005. Utkarsh,
So 355.
Hussain,
Alpha, sir. 005.
Vivek,
005.
Sujal,
Bravo, sir.
Swati, Nikki.
005.
Okay. All right. The drift is 5 degrees to the port. What do you do to allow for the drift and still maintain on track? You apply correction in the direction opposite to port because your drift is towards the port. So what will happen to your heading? Your heading will be to the starboard side. So 5 degrees to the starboard, what will be your heading? 0, 0, 5. Now, if you are at 0, 0, 5, where is the station with respect to you? Measure clockwise. What do you get? Everybody, I'll ask
355.
answers again. Jeet, Nandini,
Option B.
Nikki,
Sir B.
Hussain,
Bravo.
Vivek,
B.
Utkarsh,
So bravo.
Swati. Swati is not there. Okay. You understand how? Now, this is another confusion that would come in the exam. Simple. Port drift 5 degrees, it means you are right. The aircraft will be shifted 5 degrees this side. But what do we do to allow for it? We change our heading in the opposite side by the same value. So drift 5 degree port means your heading will be 5 degree to the starboard. From 0, 0, 5 degree starboard, heading would be 0, 0, 5. So I'll make a purple aircraft to show you allowing for the drift.
So we always allow for the drift.
We always allow for the drift, yeah. Whenever we are not allowing for the drift, then imagine that you have a track error angle. You have a TMG then. Simple as that. Here there is no TMG. Nothing. Simple. So I'll make a blue, ocean blue, some color to show what will happen now. At 900, because your drift is to the port, your aircraft would be 5 degrees like this. This is how it is. Drift 5 degree. Why? Because your required track QDM was 0, 0, 0. So you're now maintaining 0, 0, 0 by making a correction 5 degrees to the right, allowing for a drift 5 degrees to the port. This is how the confusion will end. Drift 5 degrees port, it means your heading is to the opposite side. You're allowed for the drift because you're maintaining your QDM. Remember that. And now I want to know where the station is. So from 005 clockwise up to this purple point, I get RB355. So my correct option is Bravo. Very good, Sujal, Mukul, and Utkarsh. Others, this confusion was legit, and your answer 005 as per the confusion. I knew you would say that, but now I hope you have understood why and what the confusion was. This point you should never forget. Mukul was quick, and quick, he made a mistake. He added 5 degrees, 365. Then he realized 365 cannot be, so he said 355. See, even he made a mistake. Utkarsh realized the definition clockwise. Sujal was observant enough, he took his time. Others, we were very quick to determine, okay, drift, you reduced 5 degrees, it was 355 and you measured 5 degrees to the right. You were right when you calculated that way, but your understanding for port drift was opposite to how it is anticipated in the question. It's not your fault, it's how the questions are drafted, it's how the literature is in aviation. So drift 5 degrees port, it means your heading would be opposite side by the same value. Remember that. We have to account for these things in two separate ways, whether you are on a TMG or not. Actual track, required track, and so on. Right now, we are assuming we are maintaining it. We understand one question, it could give you so many different variants, and they could still make 20 different questions out of this one situation. And then they will induce a VOR and talk about radials over there. And then they'll talk about drag error angle and TNG. Anything can happen because this is the real stuff. Anything could happen depending upon the weather patterns. And because of that one change, everything else will change. Our basic concept, does it change our understanding as to what is happening with respect to what? Does that change? No. Then why do you think you will ever be confused? All you need to work upon is this understanding. Personally, you have to work upon it. This should be your intent. That verbally saying something, whether I'm able to understand or not. Now, this example was straight, simple, and no when 000. The question could be changed to you're maintaining a QDM of 270 or 135 or maybe 133 to the station, or maybe they'll give you a QDR and then they'll ask you RB because your radial is simple. Radial is just very simple. That's why we're not emphasizing much on it right now. When you introduce and you'll see, okay, this is the radial. Whenever I'm on it, it will not change. QDM, QDR changes, to and from changes. That's where you will find 15 to 20 questions eating up your marks if you're not thorough with it. With this simple logic. And you have to practice this. You have to give yourself certain situations. And then you have to share with me, sir, is it right or is it wrong? And when we are getting free time, I'm assuming my students are revising and making everything thorough. At least one day you should revise in your holidays, okay? There is a reason we give breaks. Maybe I have not instructed it before, but it is to do thorough revision from A to Z that you have studied for the subject. It is important so that you can give me an update. Sir, these points are still weak. These points I have mastered. Are you following me? Otherwise, it will take 1.5 months to do the whole syllabus. But you know what the outcome is? Half of the things you would have not mastered. There will be confusions. Simple. We need practice, right? And we need time to practice. That's it. And how did it all start? It started with understanding what a heading east-west is when answering about deceleration error. A simple thing as deceleration error is minimum at north-south heading and maximum at east-west could be complicated with the understanding of RBs or QDMs also. So I want you all to open up your sheet on your errors, go through the points, look at them and discuss with me if you have understood them. I'm going to ask a few questions. You have to look at the sheet and tell me whether you have understood or not, giving me the answer straight away, looking at the sheet. I just don't want the answer. I want to know if you have understood or not. Okay. Is the exercise clear?
Yes.
Hussain, I cannot see you. All good, right?
Affirm, sir.
So the question is for Utkarsh. My magnetic compass shows 270 as my heading, while the aircraft is reaching towards the destination, preparing for approach. Which error will the aircraft face and what will happen to the reading? Acceleration error and the compass will overread. Deceleration error and the compass will underread. Acceleration error and the compass will underread. Deceleration error and the compass will overread. Whenever I'm giving you all a question, please write it down. Your compass gives you a heading to station 270. The aircraft is approaching the destination in its final stages. Now, approaching the station final stages is a hint for slowing down of the airspeed. Okay. It means deceleration. And whenever you are doing deceleration, you will have deceleration errors. Why will a deceleration happen? Because you're reducing your speed. You're reducing it from 140 to 120 in process of reduction. That is deceleration. Okay. Now complete the question. Which error exists in your compass and how will it behave? Everyone, okay, write down. Done? You can write in short codes and all. Just for your reference, it should be there. Write a big Q so you can always go back to the question. Option A, acceleration error overread. So you will write AEOR. Simple. Acceleration error overread. You don't have to do all donkey work now because you've already done these points. You can write your own short codes for your own understanding. Option B, deceleration error underreads. DEUR. For your reference, okay, exams might not use these shortcuts, but for you, this is for you. Option C, acceleration error underreads. Option D, deceleration error overreads. Now, look at the notes, look at the question, and see whether you understand how to answer this and whether you can come to the correct answer or not. Utkarsh, yes.
So,
If you don't have the notes, it's okay, Utkarsh. You can take your time, go through the email. I'll give the question to somebody else.
so sir, I would like to try.
Okay. What's the correct answer? Everybody prepare your answer in your heads, okay?
So, deceleration overread.
Okay. That is
Delta.
option delta. All right. Nandini?
Sir, option B, the acceleration is underread.
Okay. Now everybody tell me 1, 2, 3, 4. Option A, B, C, or D. Mukul?
Sir, I just need one. I'm deciding.
Okay, fine. It is okay if you look at your notes. Okay. I have shared the email for Compass, which has, I think, handwritten notes also included that I have written. 2 pages. One page has 3 tables, columns, and one has last column. That is the key here for you to refer right now. Okay. Jeet,
So which hemisphere are we in?
good question. Not given to you. Which hemisphere?
Bravo.
Okay.
Deceleration.
Vivek?
But I think the question is incomplete because the hemisphere is not mentioned.
So what will you answer here?
Alpha.
Alpha. Okay. Sujat?
Bravo, sir.
Swati, are you there? Nikki?
Bravo, sir.
And Hussain?
So just a doubt, how would you know if it's acceleration or deceleration, the aircraft?
Because the aircraft is in its final stages for approach. That was the key. I just said it means the aircraft is, the hint here is deceleration.
So bravo.
That's why they asked which error. As per the question, this is the most appropriate answer. Whatever your answer is, you should always take one question. Everybody done, right? Giving their answers. So if no hemisphere, yeah, Mukul, you're left, yes.
So for me, it's bravo if it's another hemisphere.
Yes. Okay, I have your answer. So if no hemisphere is mentioned, okay, then you go with northern hemisphere example. All right, the first answer that comes. And when in northern hemisphere, the answer is on a westerly heading, that is 270. So QDM to the station, that is your heading right now. Nothing else is mentioned. Due to deceleration error, you underread. Why do we say it is deceleration error? Because the hint was it is to approach and final stages. We don't know if it's landing or what, but that's the only hint we can pick up right now as per the question. So during deceleration on a 270 heading as per the notes, it's the third line in the second table, deceleration. In the northern hemisphere, it underreads. So that's how we come to the conclusion. Okay. Vivek, how did you make your answer and give me alpha if you want to explain or if you have understood the correct answer?
Yes, sir. Sir, I had a network issue. I had just wrote it. Heading is 270 to the station.
Uh-huh.
When I had asked whether we are accelerating or decelerating,
It is deceleration, approach final stages. 270 is the heading.
then my answer would be Bravo.
Very good. Nikki? Good.
Yes, sir.
All good, everyone? One by one? Understood how to give an answer, how to understand, how to study.
Yes, sir.
Yes, sir.
Your challenge right now should be all that you have learned or studied or attended sessions. Revise, master, and get back to me, sir. This I think I'm confident, this I am not. That update I need. Okay. So we cannot go back in time. So whatever free time you get, your task would be to do it by default. You should not need my instructions to do it. I'm expecting you all to come back to me. Like message me, drop me a message, send me a snap. So this is weak, this is good. This is weak, this is good. Whenever you're revising a point, you have to give me an update. So this I'm good. So this I'm bad. So this I'm good 50%. So this I'm good 75%. Anything that works for you. But positive and negative, I need to know where you stand. So if I would have not asked Nikki, everybody else is giving me correct answer. How would have I known that she did not grasp it? I would have assumed everyone is grasping it, right? This is how instructors always assume that everybody is grasping it. But that is never the case. Your doubt could be different, your doubt could be different. So you have to share those doubts with me. That will happen when you revise also. You follow. That is also as important as learning new topics. Understand, mastering the ones that we have done. So we'll do one more question before we done with this exercise. And if the question would have mentioned hemisphere, and if it would have been southern hemisphere, then what would have been your answer? Write down new question, same question as above, but in southern hemisphere, same options.
Delta.
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 Check everyone. Mukul, your answer is pending. Nikki,
Sir, Delta.
Nandini,
Option B.
D or delta, Nandini? B or D, I don't know. So delta or bravo?
Delta.
Nikki, how about you?
So what is the delta option? Delta question?
Question or option? The question is as same as above, but in southern hemisphere. That
The
is
option.
option. Jeet, read out the options for Nikki. A, B, C, D.
Alpha is acceleration and overreading. Bravo is deacceleration and underreading. Charlie is acceleration and underreading. And delta is deacceleration and overreading.
Prakash, Nikki, take your time.
Sir,
My
delta.
answer would be Bravo.
Vivek, your answer.
Bravo.
But the question is in southern hemisphere. Check again. Are you sure? Bravo.
Yes, sir.
Why? Justify.
So in my notes, it's written that compass overread. Sorry, sir. I had read it for 09 and 0.
Very good. Check your heading. Very nice. Check your heading. Be careful.
Yes, sir. Sir, it's delta.
Utkarsh, you there?
So delta.
Good. Good, everyone. Do you understand how to make use of these points? Your job is to just memorize now as a student. That without open book, you can give the answer. That's the last thing that you have to do. Understanding is enough. You need to give some time, spend some time, work it out nicely, enjoy it, because everything, basically talking about, directions, it all comes down to the cardinal points clockwise from north. And then the second level of understanding would be to and from. Third would be the definitions, heading, track error angle, relative bearing. And the fourth would be what are the differences. So we know QDM, QDR, that will be with respect to a station. Then we'll have relative bearing with respect to NDB station. And then one more thing that we'll add in further class would be the radius, that is VOR radius. That's it. Okay. Take your time and work upon these things. Concept is important. Revision is important. Now, what we can do is we can break. It's 1.5 hours. And I want to start, before we go ahead with, what do we say, gyro instruments in particular. So I'll tell you, as per your syllabus, what are important gyro instruments. Directional gyro, DGI, artificial horizon, turn and bank indicator, turn coordinator. And then remote reading magnetic compass, which is also known as slave gyro compass. A gyro compass that works, a compass that works with a gyro. Now, about all these things, you have to study points like construction and principle of operations. What are the different components? What are the applications? What is the construction mounting on the aircraft? If there are any errors. These are the types. And then obviously, how's the display? How the display looks like for every instrument. So I'm working on making a table to make it easy for you, because there will be chances you'll be confused whether there is one axis or two axis or horizontal or vertical. We will be starting with a slave gyro compass. So we will see how the mechanism works. There will be terms like the correction rate is 3 degrees per minute. It means if your magnetic compass is showing 09 at 0, and if your gyro, okay, your gyro in your remote reading compass, the slave gyro, these are two different names. Okay. One other instrument that you have to work with. If we say that there is a drift in the gyro part, we know drift is just the like aircraft drift. If we say the drift, okay, with respect to our magnetic compass is 90 degrees. So if we say they two are out of phase by 90 degrees, basically for them to work, your gyro and your magnetic compass should have the same indication, that is the same phase. Phase, now it talks about certain electric currents and this and that, but it will get too technical if you directly jump into the technical terms. So if your gyro is 90 degrees out of phase with your magnetic indication, then the correction rate as per 3 degrees per minute, how much time will it take for your gyro to work out 90 degrees? So you divide 90 by 3. How much do you get?
30 minutes.
30 minutes. So your gyro will take 30 minutes to correct itself, and only then you can look at the respective instrument to use or follow it for heading purpose. That is your heading indicator, basically. The instrument. that actually you use to determine your heading. So this one key point I'm already given you. The correction rate is 3 degrees per minute. Now you know if it is out of phase by 150 degrees, how long will it take? It will take more than 30 minutes. 3 5s are 15, 50 minutes for your gyro to just, people finish flights in less than 15 minutes at certain sectors. So we will have a rapid correction system also to correct this in a matter of few seconds. These are the two key points that you learn about gyro compass. Then I'll show you a small construction as to one input will be magnetic. The compass directly does not measure. There is a flux sensing unit. Flux, we know it's the magnetic forces. It senses and then it guides the compass. The gyro senses and then it guides the compass. The both values should be the same. That will give you the most accurate heading. Why do we use it? Why do we complicate things? Because a compass has deceleration and turning errors. But when we use it with gyro, we don't have deceleration and turning errors. So here, even in a turn, looking at the heading indicator, it will not overread or under. So if you have to roll out at 315, looking at the heading indicator, you roll out at 315. Not to worry about overread and underread. So all these errors will be minimized. But these errors will be there when you're just looking at the compass. But when you're looking at the heading indicator, which is your slave gyro compass, then no errors. That's the whole point about the slave gyro. But because we have to focus on certain technical points, we have to go through a lot of it to understand what could be which question. Right? Everybody with me? Expectations are set. What we are going to do in future. We need time to cover, right? It will take time for you to read and understand. Similarly, then after this, we will quickly go through DGI, AH, turn and bank indicator, and turn coordinate, like that. So that will be our plan for gyro. Right now, we have sorted out one important part which you have to practice again and again. The basic understanding. This is to do with your DR navigation, velocity triangle, and so on. These questions. This basic, I cannot pinpoint what is the topic as per syllabus in this point. What I was teaching right now. It is everything basically. Okay. Now, after the break, we will do the basic of general navigation, understanding what is a dLat and a dLong and how to find two important things known as convergency, what is a great circle, what is a rhumb line, and what are their importances. So this will give you a head start on the basic aspects of general navigation in determining distances. These things that we learn are only to determine what will be your distance to reach from point A to point B. So that is the purpose of learning convergency, great circle, dLat, and dLong. Okay, you understand? To determine the distance, then it is not related to directions. But then to travel that distance, you have to follow certain directions known as great circle track or rhumb line track. So the distance shortest will be great circle. So the track followed will also be great circle track. So that will be the purpose. It's very easy. And if we have time, then I'll give you certain formulas to calculate vertical component magnetism and horizontal component. And then we have to also start looking at what are projections and how these lines on Earth are projected on chart. Okay. So expectations are set. Let's see how it goes. I've taken 5 minutes extra, so I'll give you 5 minutes. Everybody okay? Coming back at 3:20.
Yes.
All right. 3:21. Good. Let's come back and get with an open mind. Let's look at dLat, dLong, convergency, and stuff like that. 3:20. All right. Welcome back, Mukul. How do you read?
Radio 5, the time of my QDM.
Sujal, welcome back. How do you read?
Radio 5, sir. Victor Tango Sierra Sierra.
Radio 5. Nandini, welcome back. How do you read?
Radio 5, sir.
So Radio 5. Nikki, how do you read?
Sir, Radio 5 Victor Tango November India Kilo.
Okay, I read you 5. So, okay, Jeet is back. Welcome back, Jeet. So we are going to, do you remember when we were doing compass, we were talking about Earth's magnetic forces. Correct, Mukul? Jeet?
Yes.
So we spoke about 2 forces or 3 forces. There are 3 forces, like total magnetic force, horizontal, and vertical. Okay, so these are the Earth's magnetism or Earth's magnetic forces, however you want to call it. How do we talk about these forces? We can also say these forces are lines of flux, magnetic flux. Now, the other day we made a diagram where we shown that the flux lines come from the North Pole and go to the South Pole, right? Then Mukul and Neha brought it across that, sir, in the textbooks, we see that the line are coming from the South Pole to the North Pole. And that is what is used as a convention in the textbooks. Okay. So I'm going to make that correction in a way, but I'll show you the confusion that can happen. And then we are going to talk about how to find the value of this magnetic force. There are 2 or 3 formulas that you can be asked questions on based of that. Okay, and we are going to do that. What would be the formula related to? Is it to do with magnetic strength? Now the magnetic strength is known as magnetic field intensity, and that is measured in units Tesla or micro Teslas. This is one important question that they can ask you. Micro Tesla is a unit to measure your magnetic flux intensity. It is the strength. Any magnetic intensity less than 6 microteslas is insignificant to affect you. 6 is the word. That's all that you have to learn about Tesla and the unit to measure magnetic field intensity. So, can you all see the screen? Can everybody see the screen?
No, sir.
Okay. Nikki, can you see the screen now?
Yes, sir.
So every time when you make Earth, you also make an axis. Okay. And so this is the Earth, and we make an axis, and the extreme points of this axis are known as poles. The one in the north is the North Pole. I'll write magnetic North Pole here and magnetic South Pole to determine that we're talking about magnetic north right now. Okay. So this magnetic North Pole is given blue color, and this magnetic South Pole is given red color. Okay, this is important. So whenever you'll have a freely suspended bar magnet, okay, on a compass,
if you have a compass like this, then the compass red pole will be aligned with the Earth's north pole, and the compass north pole will be aligned with the south pole. Okay, so we call these points, there's a new term that you learned today, we call these points as north seeking pole. It is the north seeking pole of a compass. I'll say this is magnetic compass, right? And this in blue is south seeking pole of a magnetic compass. But in actual, this is the compass north pole. This is the compass north pole of the bar magnet. It is not the compass north. The compass north will be the north pointed by the north seeking pole only. But for this bar magnet, this is the north pole, and this is the south pole for the bar magnet. So firstly, you have to clarify this for yourself, that for the Earth, the diagram looks like this. Okay. Earth's north, south, and this is a compass, and that's what is happening to the compass. Everybody clear so far? Yes, no, maybe?
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
Yes, sir.
Magnetic field or forces, will make them in green here. They come out from the south and they go like this. As a convention, we use this everywhere. Okay. So if we have made a diagram before where we have made it in the opposite direction, you will correct that diagram there also, and you'll make this new diagram right now. Just correct that so that whenever you are studying, you don't get confused, and make this new one. Now, the closer the lines are to each other, the stronger is the magnetic intensity. So you will see that lines near to Earth are closer compared to the lines away from the Earth. The another point for lines of magnetic flux is the closer they are, stronger is the magnetic intensity. So Earth is surrounded like this. Now you have to focus on this point, that for the compass bar magnet inside this diagram, the fields of force will act from the north seeking pole to the south seeking pole like this. This is where there are chances that you can incorrectly mark. So every magnet has these lines of magnetic flux going from one pole and getting into the other. And the force comes from south and goes into north as an accepted convention all across the world. Are we all following?
Yes.
So it is from the south to the north. Why? Because the only explanation is when you're on the north pole, if this is the compass needle and this is the north seeking pole, then this north seeking pole is dipped like this completely. So it feels like there is a force pulling something down. So the magnetic force is basically a force of a pull force culminating from all directions into one point, that is the north pole. And that's why these level lines make sense. But there'll be certain times when it will be told to you that it travels from north to south. That will be when they are referring to north seeking pole to south seeking pole. For you, that much relevance is enough. One thing I want to make sure, the literature for aviation studies and the literature for other physics and all. Although the same topics, the concepts discussed will vary in the language used. So whenever you're referring extra, look at the source. And if the source is not from aviation, then the language would be different. A few more terms would be discussed with you, but the basic concept will remain the same. So do not be scared thinking you're not being taught something correctly. But as a good rule, we have the best notes that we can follow, but it's always good to go through your own study material also. Just keep in mind that that level of understanding is not required for you. Those words are not required for you in aviation. Just today, when I was researching a little bit, I came across a physics forum to see the discussions, and the terminology used by those physicists is completely different from the terms that we use. And if you refer that on your own, you can have trouble understanding what they mean. It is like that. It's just the language and the words that we use. For us, even a word as good as flux, intensity of flux, that's it. There's nothing more complicated than that for us to understand so far. Okay. A little bit understanding of electric current is very important, electromagnetism, because an AC, alternating current, there are two types of electric currents, AC alternating and DC is a direct current. I'll show you. This is the AC current, the waveform. Current is the movement of electrons in a conductor. When the electrons are moving, they move in this direction like this, just like a radio sine wave. And DC current is like this. DC. The DC is generated from a similar device as AC is generated, but in that, the negative half of the sine wave is removed or skipped. So we get the positive, positive, positive. For your general knowledge, AC is the one that will cause you electric shocks, while DC does not cause you electric shocks. Okay, in simple terms. Your mobile phone batteries, all portable devices, they all have DCs, but your aircraft house supply is AC. That's why for charging any device, you need an adapter. That adapter is basically a device that converts AC to DC to transfer it to your power source, your laptop battery, your computers, and everything. That's why that's the importance of having adapters. Okay. And the point about AC is that whenever AC is induced in a conductor, there will be magnetism also induced in the conductor, like this. So that is the importance of understanding AC and magnetism, because electric current, the AC type, will induce magnetic flux in the conductor around it. That is known as electromagnetism. It happens everywhere. This is why we say aircraft has its own magnetism, because of all electrical and electronic components. So just remember this much. AC induces magnetism in conductors. Now, all conductors will not be converted into magnets, but the area around these conductors will have magnetic fields or lines of flux. Okay, remember this point. Around and in conductors. This is the basic concept, because when we will be doing slave gyro, the slave gyro you will see a lot of terms talking about a coil around a magnet. What is a coil? Coil is nothing but a conductor only. Simple as that. Okay, so coming back to this point, to Earth's total magnetic component. All right. this is represented by T. Earth's total magnetic component is represented by a big letter T, that is tango. T for tango. Earth's total magnetic components. What are the two? One is H and one is Z. Z as in Zulu, H is in hotel. We will write a few points about it. Earth's total magnetic components. So the first point that you'll write is Earth's total magnetic component is represented by T. It makes sense the way we have written it, but it's good if you write that point. Now this is divided in 2 points, 2 parts, okay? We have H and we have Zulu, okay? What is H? Who can tell me?
Horizontal component.
Horizontal component.
Horizontal force, and Zulu is vertical force. All right. Now you have to remember a few things about compass. Okay. A magnetic needle freely suspended aligns itself with Earth's total magnetic field. All right. The red pole. Now, what is the red pole? It's the north-seeking pole of the compass. The red pole of the compass. Now, in bracket, you will write, okay? The red pole of the compass needle will tend to point vertically downwards. Now, which part or where on Earth will your compass needle point vertically downwards? Very important. Who can tell me? Is it magnetic north, magnetic south, or equator?
Red poles,
Magnetic north.
north or south.
The red pole of the compass needle will tend to point vertically downwards at the Earth's north magnetic blue pole. Write it in these words. The red pole of compass will be pointing vertically downwards at the Earth's north magnetic blue pole. This concept, although we have made it very easy, it is something which half of the students will never know. So you have to not forget it, the red and blue. And what is the red? Now the red pole of the compass needle will write down here in bracket is the north seeking pole. That's why. Now write down the next important point. The compass needle what will happen to the compass needle when it is midway? That's what we are writing. Okay, the compass needle will only be horizontal. The compass needle will only be horizontal when midway between the Earth's magnetic poles. Then in bracket, you will write this point is the Earth's magnetic equator. These are the key points in your exams you have to focus upon. Although the topic is simple and you have learned it, but when it comes to the examination, you can make mistakes. This is how we avoid making mistakes. These crystal clear notes are really important for you to read and understand at least twice before the exams, okay? Continue this point. Elsewhere, every other place, okay? Elsewhere, it will dip. Highlight the word dip, D-I-P. It will dip from the horizontal until reaching the magnetic poles where it becomes vertical. Now this dip is our takeaway today. The dip is what we are doing it, to introduce the dip, to understand what the dip is. Magnetic dip is nothing but this is horizontal on the equator. If this is the north-seeking pole, this is dip. The value of dip will vary or depend upon the latitude or the magnetic latitude. Write down. The value of this dip will depend on magnetic latitudes. Now, where will the dip be more? Option A, 45° north. Option B, 55° north. Option C, 35° north.
Bravo.
55 degrees.
So 55 degrees.
55 degrees.
Everybody following? Okay. Write down. We use SI units. Okay, we use SI units, that is Tesla, okay, to measure magnetic field strength. It could be micro Teslas also. Now, as we are talking about the Earth's total force, it was resolved in two components, vertical and horizontal, right? So, about H, write down. What do we know the most important point about H? H is known as the directive force. Very important point. It is the directive force for your magnetic compass. Because of this resolution, you get your directions. Write down about the directive force. The total directive force. So we are not talking about Earth's total magnetic force. The total directive force acting on a compass needle will also include. This is a MCQ, all right? The total directive force acting on a compass needle will also include local magnetic effects, if any. Otherwise, directive force is only affected by Earth's magnetic field. These are simple words, but when they are drafted into questions, the same point, confusions can happen. And you might very well miss one point. Now write down about Zulu, the vertical component. Zulu has importance. Earlier, we were just talking about Zulu being not good, reducing directivity. But what is the importance? The Zulu or the vertical component has importance in magnifying, okay, the vertical soft ion in an vertical soft iron magnetism in an aircraft. What is soft iron magnetism? Aircraft has a lot of ferrous materials out of which a lot of equipment components are made. Okay. Soft iron magnetism is like that, affecting certain ferrous materials on a temporary basis. Now the same can be divided into horizontal aircraft magnetism and vertical aircraft magnetism, or horizontal soft iron aircraft magnetism and vertical soft iron aircraft magnetism. The Zulu increases the intensity of the vertical soft iron magnetism in the aircraft. The soft iron and hard iron are two terms. Soft iron magnetism has temporary effects, but it is not good. This point about Zulu is very important. Write down the next point. As we move or travel from equator to the poles, the compass needle dips, like we discussed above, from the edge. So the dip is happening from the edge. Edge was horizontal, making an angle called angle of dip, theta. This angle of dip, that is theta, is 0 at equator. Remember, magnetic equator, okay? And theta is 90 degrees. This again is important. In bracket, write max 90 degrees at poles. 0 in bracket, you can write minimum. So one more point that we are learning today is about the value of the magnetic dip angle. The magnetic dip angle is 90 degrees at poles. It means the maximum it can reach is 90 degrees. And 0 at equator. So if I show you equator, what is the latitude value of equator? 0, 0 degrees like this. So what happens? H and the magnetic dip angle is 0. It means this is my total angle like this. I'll show you. H is blue. Sorry, H is black here. We'll make Zulu green. And why make horizontal? We'll make vertical for Zulu. And we'll have total in blue. So H and blue, it means at equator, your dip angle we cannot see at all. But when I show you at 45 degree, north and south both, the horizontal reduces, okay, and the vertical increases like this. Vertical increases from here, and the angular difference is measured with respect to the total and the horizontal. So although you will see that the magnetic dip angle is related to the horizontal being reduced and the vertical being increased, you will never be able to find where the angle is because you'll think this is the angle then, while this is not the angle. Although the vertical is increasing at this point, the angle is always made when the dip is with respect to the horizontal only. That's what we are talking about. And in this case, your magnetic needle would have actually dipped by this much point from the horizontal. So the angle would be this. This is theta is equal to 45 degrees in this case. So this is the magnetic dip angle. This is the horizontal. And this is the dipped needle from horizontal. Remember this point. It looks easy, but it is very confusing. It is with respect to where it should have been to where it is. That is the dip angle. The only component you have to understand for dip angle is just the horizontal component. But when we talk about three components, then the total, the line from the start of the vertical and end of, start of the horizontal and end of vertical gives you this. What will happen at 90 degrees? At 90 degree, north or south. But right now we're only talking about north. In the south, the opposite happens, remember. Here also we'll make a correction only north. Here, this was my horizontal line at the equator, but my magnetic needle has completely dipped like this. See, I'm showing the north seeking pole. That's why I'm making red. So my magnetic needle ideally would be like this. So what angle is it making? It is making this angle with respect to the horizontal. That is 90 degrees, theta. So this is the angle that the needle is making. This is the angle of dip. But when we resolve it in components, how it looks, how does it look like? Your horizontal will be none. Your vertical would be this much. And your total would also be as good as your vertical, right? Like this. If I have to show you at 60 degrees, just for your reference again, at 60 degrees north, what will happen? This is my horizontal. My needle would have dipped this much over here. My magnet, this is my magnet, look from the side. The north seeking pole is dipped at 60 degrees. What does it mean? It means this is your horizontal component, very less in black. This is your vertical component, very high. And this is your total component like this. So the angle is always this between your total and your horizontal when you're sketching it. So be careful about it. It appears to be, when you're making a diagram, the angle of dip looks like this, but actually it is from the horizontal and the dip of the needle. Thus, write down angle of dip is between horizontal and the dipped not seeking pole of the magnetic needle. Thus, angle of dip, theta, is between horizontal and the dipped not seeking pole of the magnetic needle. Are we all thorough with this?
Yes.
Only Mukul is interested. How about others?
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Yes, sir.
This is important. This is not clearly mentioned in any book. But now you will know. Okay. It takes a lot of time to understand this. Trust me.
Sir, how do we navigate over pole? Like, how do we find our magnetic direction?
Because we use those gyro slave compass and all, we don't look at the magnetic compass. We just look at other navigation aids that are not affected by these problems. So it becomes easy that way. We fly close to the poles. It's not a problem now. Write down quickly, everyone, the relationship between theta, h, Zulu, and T, okay, can be drawn as below for solving sums. So over the North Pole, if you just rely on your compass, the needle, because of the construction of the compass, will really not get a physical chance to dip. But because it will be dipping to its physical limitations, the readings will not be accurate. So we cannot depend upon it. So we have many more instruments that don't create all these problems. But yeah, this can happen on a basic compass. That's why you learn it. Okay. So one thing, now you will see a new thing in the diagram. Everybody make it, okay? See, this is a half diamond pointer showing you magnetic directions. Okay, write down, this is your magnetic meridian. Magnetic meridian as in lines joining from magnetic north pole to magnetic south pole. Magnetic meridians, we can write lines from magnetic north pole to magnetic south pole. I'm just showing here. If this is the magnetic meridian, then your directive force, let's give red color to your directive force. Your directive force is this, H, determined by an arrow acting along this, H like this, Zulu, like this, all right? And your total force, because your needle will be acting in this line, something that looks like your velocity triangle, T. So in this situation, where is my dip angle? This is my dip angle like this. Dip angle. Theta. This is the relationship. Okay. Write down a few notes over here. The line along which H acts, we're talking about the directive force here, is known as magnetic meridian. Again, if I would have not given you this point, it would have been so difficult for us to understand if that's the answer in a question. That's why, see, understanding, then reading, then revising, going deeper into it, working out the correct terms is very important for us. Next note. H and Z are always perpendicular to each other. This is again important. This will help you realize from the diagram that T is not perpendicular, but H and Z are perpendicular to each other. Write down the formulas. Number one, the first formula that you get from this relationship is to give you let's say how to find vertical component. You have a scientific trigonometric term, tan, which we will use on a scientific calci. Zulu is equal to tan theta into H. If the value of theta is given to you, you can use that tan theta multiplied by H, you will get Zulu. Second formula you get is looking at the same, tan theta is equal to Zulu upon H. What will you do if they want you to find magnetic dip angle, that is theta? They will give you certain values, Zulu and H. You divide this, and this tan theta, if you want to solve, it will become inverse of tan. So there is a function known as inverse. When you inverse it, whatever value you will get here, you'll use tan inverse this value, and that will be the value of your magnetic dip angle. I'll show you how to do it on scientific calculus. Therefore, here you can write theta is equal to, write in words, okay, tan inverse Zulu H, like this. This is the angle of dip. Now the third formula that we get is to find the horizontal component. Horizontal component can be found as Zulu upon tan theta. Very simple. Then another way to find is horizontal component. We can find total component, but total component could not be found directly initially. So we use the formula t square is equal to h square plus z square, like this. Then you can find out the square root. So first you find out h square into z square, add it. The answer will be t square. So the t would be square root of the answer. That will be your total force. For t, we have also a formula where t is equal to h upon cosine of theta. So there are total 5 formulas, or you can write like this. Keep these formulas handy for quick reference. There might be a question or two that will come across where you'll have to quickly feed in the values on your scientific calc and get the answers. This is the only place where you have to find inverse in your whole navigation syllabus. But I'll teach you how to find that function on a scientific calc. Sorry. Now write important notes again. Note a very important theoretical questions. Lines joining equal magnetic dip. So there will be lines on charts. Okay. If you follow those lines on charts, those lines will have certain directions. It will mean that if you follow this line, when you are flying, you will have equal amount of dip. Your dip will not change. Such lines are important to show us in certain aspects. Lines joining equal magnetic dip are called isoclines. ISOCLINES. You can call it isoclines also, isoclines. Very important word. Next point. Lines joining zero dip are called ACLINIC, aclinic or aclinic lines. These are another two important theoretical points. Zero dip, aclinic or aclinic, equal dip, isoclines. Now, talking about equal dip and zero dip, remember, it is very good to remember about variation. Remember, we are talking about variation, the difference between true north and magnetic north. Lines joining places of equal variation are isogonals. Another important question. And then lines joining places of zero variation are agonic lines. Students are always confused between aclinic and agonic. That's why I'm introducing these 2 points here. There are lines mentioned on charts. So we were talking about if the charts have two directions. Also write this point, okay? Write this note 4. Lines drawn on navigation charts and maps show Earth's true directions. Variation is given on these maps and charts. So you solve for the variation, then you find your magnetic direction, then use your magnetic heading indicator to follow directions. That's how we actually do navigation as per theory. But the real job is simplified. But this is how, as we say, a simple airplane with simple instruments, you need to know how to do this. And that's why it is a part, because you are at the basic level of your CPL career. So you need to know the basics, how to do, what to do, when to do. Remember, I'm just giving you all a reminder, C, D, M, V, T. Okay. First, we have true direction on chart. On the chart, we solve for variation, get magnetic. To follow the magnetic, we need to work out deviation, which is the difference between magnetic and compass heading. This is how it works. Rules of thumb. Write down these 2 rules of thumbs, everyone. Actually, these are 4. Okay. Whenever your variation is east, your magnetic is least. So your variation and magnetic and deviation and compass, that's the link. To understand this theory, it will easily tell you whether you should add or subtract if you follow this. If I tell you your true direction is 200, variation is 5 east. So variation east, magnetic least. So your magnetic would be 200 minus 5. That will be 195. This is something you can find on your nav computers also, CDM VT. I have shared the links. Students who don't have nav computers, the link to access the NavCalc is in the group, notification group. Keep playing with it in your free times and keep exploring the nav computer as much as you can. Screen is acting a little writing these rules of thumb, make an important note. It is all to do with your compass directions and everything. If your variation is east, and if your variation is west, whenever your variation is east, your magnetic direction driving to east is least. That's why this formula works. East, least, west, best. And variation west, magnetic, best. As per this, if I have to solve, what will I do? If I tell you your direction on your chart, your true direction, the direction in the chart means true direction is 201. Okay. And I tell you your variation is 11 degrees east. What will be your answer here? Who can give me the answer?
212 degree.
190.
No, Vivek.
90.
Vivek, think about the rule of thumb. Variation east, magnetic least. So the answer that you get for magnetic direction should be lesser than 201. Yes. Everybody focus. Jeet, you're not responding.
I did.
Everybody is exhausted, I know. Little bit more and we'll be done, okay? You can do it, everyone. Sujal, Nikki, Nandini, Utkarsh.
190.
So 190.
190. Very good. Now, if I tell you your magnetic heading is 105 and your variation is 06 west, can I find my true?
99.
If variation is west, magnetic is best. So answer will be lesser than 105. Vivek?
Yes, sir. 99.
99. 099. Remember, everyone answers in individual letters because these are directions. Utkarsh, are you following?
Yes, sir.
Now, your second set of your thumb rules is about deviation. Deviation east, it talks about something, and deviation west, it talks about something. So deviation east is always talking about not magnetic, but the compass direction. Least, east will be least, and compass west will be best. What does it mean? My magnetic heading is 190. Okay, deviation west, compass best. My magnetic heading is 190. Now I'm telling you the deviation value is 04 degrees west. Can you give me my compass heading or the compass direction?
194.
190.
Deviation west, compass best, 194. Is everyone following? Quickly, class, come on.
Yes, sir.
Yes, sir.
Now, if I tell you that your compass indication is 271, okay, and your magnetic value is, so you'll see it on the screen now. If your compass direction is 271 and your magnetic, as you can see right now, is 105. Can you find out the deviation value and whether it is east or west?
166 west.
Deviation west, compass best. Only one student is giving me the answer.
One
What's
sec-
happening with others? Jeet, sleepy?
No, sir, I said 166.
166 west.
Yes, sir. 166 west.
150.
Yes. See, you can find that out, but your deviation values will not be that high. Okay, they'll be very close to your answer. So it could be considered 115. Now give me the answer. What is the deviation if your compass reading is 115?
10 degrees west.
And west.
Deviation west,
10
compass best. How do I determine east or west? By comparing 115 and 105. Simple. Such questions will also come in your exams. Okay. I'm giving you a few sums that you have to solve. The compass is 104. Your deviation is 6 degrees east. Find variation. Correction, find magnetic heading. And then I want your variation also. Do this. My true is 0, 0, 0. Who can solve this quickly? 6 degrees east, compass least. So my magnetic will be more, 110 by 6. And now I know my compass is 100. Correction, my true heading is 100. Compass is more, 110. Variation west, magnetic best. It means variation is 10 degrees. East or west?
West.
West.
See, I can find out any two things, but I need to know first what to solve and then what to solve. Okay, right. Do this one, everyone. 0, 1, 2. I don't know the variation. 0, 0, 6. I don't know the deviation. 0, 0, 0. Come on, class, buck up. Work against exhaustion. Come on, you can do it.
So both are 6 degrees east.
Is the answer true? Variation east, magnetic least, yes. 6 degrees east makes sense. Deviation east, compass least, 6 degrees east makes sense. Is it true, everyone?
Yes, sir.
Yes, sir.
Good.
Yes, sir.
So we'll try to see if we come across any equations when it comes to how to find a magnetic depth, the value of theta, and then we'll solve live in class to show you how to use the scientific calci. Okay, but it is important you have written down these formulas to refer when we need it the most in one place about magnetism. When you learn this much, you can be certain about doing magnetism up to a high level, all these points and everything else. Now, only thing left for you to understand is the gyro slave compass. And then everything to do with magnetism will be over in a way completely. Just that how you resolve and how to correct answers, this and that. These are simple formulas and they are easy to solve if you remember the formula basically. What is H, what is Z, what is tan theta. Good. Any confusions? I want you all to start revising as much as we have done. Don't wait for instructions or the dates. Revise and give me an update. And tomorrow we are going to meet somewhere around the same time, but I'll confirm on the notification group. Okay. Until then, study, revise, and give me a feedback. And tomorrow we will start with our dLat, dLong, everything. come with a fresh mind, like always. And we will use a lot of calculator. It's basically simple measurements, dLat, dLong, but there's a formula and we'll use a scientific calc. So if you have scientific calc, keep it handy. If not, we can use the digital version of it, the link that I have shared or any other that you're using. Okay. Good. We'll also do departure distance and things like that. They are interesting, very interesting and simple sums. So you'll not feel as sleepy as you're feeling today. But it's good seeing your hard work. Keep it up. And remember, by default, revise from start, your first sessions, whatever you have done. And keep giving me an update. So I'm good with it, sir, I'm not good with it. I'm 75% good with it, or I'm completely unaware of it. I had studied it long ago, whatever the update is. Okay, Mukul, Jeet, Sujal, Vivek, Nandini, Nikki, Utkarsh, all good with everyone? Okay.
Yes, sir.
Yes, sir.
Yes, sir, we are good. We are half asleep already, 50% asleep, sir. Is that the update? 75% asleep.
Yes, sir.
Yes, Utkarsh is 75% asleep. Similar way, I want the updates. So I'll see you tomorrow and take care. Enjoy. All right. Bye, everyone.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you for leaving, right?